My name is Megan Gimber and I work as the Key Habitats Officer for People's Trust for Endangered Species. And in this video I will briefly discuss hedges and the climate crisis. Can hedgerows help us save the world? So I'm going to break this down into three sections. Hedges for climate resilience, how hedgerows can buffer some of the impacts of climate change. Hedgerows and carbon, the evidence and options for increasing carbon sequestration using hedgerows. And lastly, what is a climate resilient hedgerow? How do we design, plant and manage hedgerows to ensure they are robust in the face of climate extremes? So let's start with hedges for climate resilience. We are already seeing the impacts of climate change. So how can we use hedgerows to help future-proof our farming and food production? How do we build climate resilience into our existing systems to ensure the viability of our farming going forwards? I'll start with livestock farming. It's likely that we're going to see increasing length and severity of heat waves. So establishing more hedges and hedgerow trees now will help future-proof livestock farming in the face of climate change by providing much needed shade. Heat stress can take a huge toll on livestock, which you'll often see crowding into any shady areas of a field on a hot day. In fact, heat stress can reduce milk yield in dairy herds. It can affect fertility, growth rates, and immune function. Now, all of this impacts the animal welfare, the health, the profitability, and ultimately the viability of livestock farming going forward. Climate change will also bring more frequent storms of stronger intensity, from which hedges provide valuable shelter. We know that livestock without shelter have higher mortality and require more food. And the shelter a hedge provides can be modified depending on our own need by adjusting its size, shape and porosity. Healthy livestock will be more resilient to other climate change challenges, and a diverse diet, which can include hedgerow and tree browse, could be a part of that. Many hedgerow plants contain medicinal properties known to enhance livestock vitality. We know this and we see it already. Turn the cows out to a fresh field of green pasture and some will always go straight to a hedge. The shelter and increased warmth adjacent to a hedge means that grass starts growing earlier in the year and continues later in the season too. This stretches the grass growing season, offering more flexibility for livestock management and helping to buffer seasonal changes. This photo also shows that in times of heat and drought extremes, hedgerows and trees can be the only green thing remaining in the landscape. Incidentally, this photo was taken this year in my normally soggy and green home county of Devon. We've just had the driest spring on record. 3 years hottest summers on record too. Again, farmers even in my normally green home county of Devon have had to feed cows in summer the silage meant for the winter months. So any resilience we can build into the system needs to be utilised. On the arable and horticultural side, again, the impact of shelter means hedges can provide valuable microclimate regulation. They moderate temperature, humidity and evapotranspiration in fields. Again, with more drought scenarios likely in climate change, the increasing scarcity of fresh water for irrigation, the creation of humidity layers to reduce in-field evapotranspiration may tip a fine balance in the farmer's favour. Climate change and biodiversity loss are intrinsically linked. It's hard to talk about one without talking about the other. And of course, we depend on biodiversity in our farming, whether we're talking about pollination services or natural pest control through predator and parasite interactions. Hedgerows provide the habitat that these farming allies need. And of course, they don't just do this for pollinators and predators, but they're a key habitat in the farmed landscape. And certainly with a changing climate, we need networks of corridors helping species migrate. Increased storm intensity and rainfall with climate change is already showing what damage it can do across Europe. It's especially bad when periods of drought are swiftly followed by intense rainfall. Dry soil is hydrophobic and it will not readily absorb water, meaning this water can flash flow, taking layers of soil with it. Hedgerows alone are unlikely to fix this, I'm afraid, but they can be part of the solution. The improved soil condition and larger aggregates in hedgerow soil has been shown to dramatically increase water absorption rates. Add this to the impact of root trickle, where water literally follows the roots into the soil. This again facilitates swifter and deeper water infiltration in the soils below a hedgerow. So it's clear that hedges can be part of this solution. So where we plant them really matters. Anything that slows down water flows after heavy rainfall will reduce waterborne soil erosion and the pollution implications of this soil, along with its agricultural inputs, from reaching our watercourses. So for many reasons, it looks like we're going to need hedgerows. Now for the really exciting bit, hedgerows and carbon, what's the evidence? There's a growing interest in the potential of farmed habitats to contribute to carbon sequestration, and hedges are gaining increasing interest. Key to understanding how much carbon hedges can store is understanding where this carbon is stored and under what conditions or management systems. This is an area of active research, and we don't yet have all the data that we need, but what we do have certainly looks really promising. What we do know is that hedges sequester and store carbon in many different areas. In the hedgerow standard trees, in the above ground hedge structure itself, we call this the above ground biomass, in the roots, and also in the soils below and around them. Now, understanding these elements separately helps us understand the opportunities to increase carbon storage in existing hedgerows. Understanding these elements together gives us the scale of carbon sequestration available to us by embracing new hedges as part of our agricultural systems. In a fantastic paper by Sophie Drexler, based on hedges in North Germany, she demonstrated that the carbon stock in mature hedges was larger than that of your average forest per hectare. More carbon stored than your average forest. This is groundbreaking. And it might come as something of a surprise. When we think of forests, we can see all of the carbon stored in the branches, in the trunks, in the timber. It's all visible. But when you break down the total hedgerow carbon stock, a much larger proportion of it is out of sight, stashed below ground. Breaking this down into a hedge's constituent parts, and it's the column at the end that's most exciting. Now this represents soil organic carbon below and around the hedgerow. Strikingly, there's a lot more carbon stored in the roots and the soil than we had ever realised. And this data is consistent with other studies. In England, Sophia Biffy and Pippa Chapman demonstrated that soil carbon below and around a hedgerow ultimately reaches a point where it stores an extra 40 tonnes per hectare more than the adjacent grassland soils, this being consistent across different pedoclimatic conditions. Now, this is a 40% increase in total carbon stored in the soils. And this carbon is accumulated over time. It might take up to 50 years for them to reach their soil storage capacity. But luckily, the fastest increases in sequestration seem to happen when the hedge is quite young. Now, excitingly, this shows that we have historically underestimated the carbon sequestration opportunities of hedgerow planting. But for those of us that are lucky enough to have retained old hedgerows, this information comes as something of a warning. There is a lot more carbon under our old hedges than we had ever realised, and the studies show that much of this carbon is re-released back into the atmosphere if the hedgerow is lost. So there's more than we realised at stake here. To me, this means that one of our first focuses should be to prevent the loss of our existing hedges, then set up the management priorities to ensure that in the future we can maintain and retain any new hedges that we plant as well, allowing them to reach the age and this impressive potential. The only feasible way to secure our existing hedges and the carbon in and beneath them is to periodically lay or coppice them. The base regrowth that comes from the cut stool represents the next generation of hedge and keeps that hedge going into the future. So with billhooks and chainsaws, hedge layers wield the power of immortality, turning what is otherwise a set of trees and bushes with a defined life expectancy into something that can conceivably live forever. Is there a superhero power more impressive than the power of immortality? So without this rejuvenation step, we lose hedges. And sadly, this is what we're seeing across the UK at the moment. And that means that we must factor this rejuvenation step in to our expectations for carbon storage in the woody biomass. So perhaps ironically, we need to periodically cut hedges down, lay them or coppice them, to keep them alive in the long term. There's a limited amount of additional carbon sequestration we can gain from increasing the size of existing hedges. But allowing hedges to be bigger on average as part of their life cycle, particularly those managed on a trimming regime, will add to their average above ground carbon biomass. We can also increase this above ground carbon by gapping up existing hedges that may have developed gaps, like this one, which now looks almost more gap than hedge. Gapping up is adding to the habitat and creating more carbon storage without taking any extra land out of production. And if we can utilise the material when we do lay or coppice our hedges, it means we don't need to immediately re-release that carbon, or perhaps it can be used to mitigate other emissions through its utility. So this is a dead hedge made from hedge laying brash. It gave instant physical protection between the lambs and the dogs on the adjacent public footpath. Dead hedges can provide a wonderful habitat, don't have to be permanent, and can be used in areas where hedges may not have established very well, like under the thick canopy of a hedge that is turned into a tree line, perhaps. On a rotation, there is often firewood that can be extracted from hedge rejuvenation. There might also be an opportunity in biochar, which is a powerful soil improver and apparently converts carbon into a biostable form, meaning we can stash it away underground for many years to come. And we can also make wood chip for mulching or for compost, and we can use this in further habitat creation. This can be a great mulch when you're planting a new hedge, for example. Next up, for the increasing the carbon in existing hedges, we can establish more hedgerow trees as and where is ecologically appropriate. The hedges in Sophie's study had a tree roughly every 40 to 60 metres, which equated to 6.8% of the total carbon in those hedges. Now, the recent definition of favourable conservation status for hedgerows estimates that hedges should have a mature hedgerow tree every 20 to 50 metres. And on top of that a 45% proportion of hedges need to be young in order to retain a stable population going forward. So perhaps there's scope to increase the carbon biomass stored here too. Now, just to be extra clear, this is increasing the standard trees, which are separate canopy layer above the shrubby managed hedge below. It is, and I stress, not letting the hedge grow up and turn into a line of trees itself. Now, hedgerow trees don't just store more carbon, they can improve the hedge functioning too. Done well, hedgerow trees improve the hedgerow habitat. They can improve the on-farm functioning of hedges, increasing the vital shade and the shelter. They can buffer the impact of management of the hedge below. So when the hedge below is trimmed, it may not provide as much blossom or berries, but the trees above will still flower and fruit, providing food for wildlife. When the hedge below is laid or coppiced on a cycle, the trees remain, providing some of that shade and the shelter for livestock and some of the existing ecosystem functioning. Hedgerow trees complement the hedge with a more stable and long-term carbon storage too. Again, the trees remain even when the hedge below is periodically cut down through coppicing or laying for rejuvenation. And the more trees we can cram in within a productive farming system, the less farmland we have to remove from food production to reach our carbon and biodiversity targets. Leaving suitable stems standing when a hedge is laid or coppiced is my favourite way of establishing new hedgerow trees. There's no need to climb into a thorny hedge with a sapling, a plastic tube and a spade. With this method, they're already rooted, already established, they often have a great structure, and they have the added benefit of preserving the genetic diversity already present in your hedge. We can also plan where we put new hedgerow trees to have the maximum benefit and the minimum disruption to our farming. Now, a diversity of hedge tree species is best for wildlife, but it also helps us bring flexibility. Each hedge tree species has a different size, shape and structure, which means that we can find the right tree for the right position or the right hedge. So if we want shade for livestock or similar, then large hedgerow trees like oaks or beeches can be put in east to west aligned hedges to cast valuable shade in the field above. If we don't, then maybe we put our large trees in our north-south aligned hedges. There they'll cast most of their shade on the hedge above, not the fields either side. We can put small hedge trees in like crabapple, damson, hawthorn or rowan in our east-west aligned hedges as and where we don't want too much shading in the field above. And we can cluster hedgerow trees in places where they're going to have the least impact on hedge management or the best impact in our farming. There is huge scope when we plan where these trees go. And of course, last but not least, we can store more carbon by establishing new hedgerows. Now, designing new hedgerows is a massive opportunity for us. For each hedge planted, we can think of its primary purposes and design its species mix, location and management to suit. This might be hill contour planting for hydrological impact, habitat connectivity for wildlife. We might design hedges which are suitable for simple coppice or laying rotations for firewood, or some that are suited to also include trimming management. We can design a hedged landscape that suits our current farming, wildlife and climate needs. There is a lot to be gained here. In England, the government have set a target of 45,000 miles of hedge to be planted or restored by 2050. Now, the main drivers for this target are the international concerns of climate change and biodiversity. But it will be farmers designing these hedges, farmers who can decide how to make these hedges best fit their modern farming needs, farmers who will be managing them going forward. So we need to make sure that the farmers and landowners putting these hedges in are aware of the potential, the flexibility and the diverse opportunity within hedgerows, that we offer them the tools to make these sorts of decisions and plans. Luckily for us, it looks like the highest annual rates of carbon biomass sequestration occur when a hedge is fairly young. So there's a lot to be gained in the first decade or so of a new hedgerow's life. And this leads us nicely to the last part of this talk, which is what is a climate resilient hedgerow? How do we design and establish hedgerows that will be robust in the face of known and unknown extremes? So to me, a species-rich hedge is sensible, with a careful balance of suitable species that complement the hedge's prime purpose and location. Now, species-rich hedges offer more for wildlife. They flower and fruit for longer periods of the year. They cater to a wider diversity of specialist species. They provide a backup food plan when one species may have an off year for blossom or for fruit. But crucially, they're also likely to be more resilient to climate change and more resilient to new pests and diseases. Similarly to the need for species diversity, I think we need to consider the genetic diversity of our hedgerows and how we can ensure that we offer the opportunity to reflect the diverse populations in any area, region or country. Genetic diversity is one of the key defences that tree species have against the variable and changing climates around them. So how do we achieve this? Are our seed collection and nursery industries currently providing diverse enough stock? How do we ensure that this is the case as we roll out our greater hedgerow planting ambition? Perhaps one way we can increase genetic diversity in our hedges is through new approaches to establishing hedges. Currently, all hedgerows planted in England, using government grants, are planted with 2-year-old whips, planted 6 to the metre, in a double staggered row 40 centimetres apart. Whilst this gives consistency, it also means we're probably just about to establish 45,000 miles of quite homogeneous, uniform hedge. What are the opportunities for expanding the scope, the diversity and the flexibility of this? Well, the Tree Council recently conducted a study looking at different approaches to hedge creation, including direct seeding into prepared soil. Impressively, hedges seeded 5 centimetres below the soil surface resulted in hedges with 65 plants per square metre and cost just 40% of what it would cost normally. Now, this was a small study and it needs replicating and expanding, but it does show promise. And it's looking like having many approaches to hedge establishment might be our best bet. After the driest spring on record in England, we saw vast amounts of young planted hedges die off entirely. Next up, we need to make sure that we have the skills and the knowledge to raise these new hedges to establishment. Here we have two hedges about the same age, about 12 years oldish. One established in what I think is the best way to raise a new hedge, which is planting it, letting it grow for a decade uncut, then laying it and incrementally trimming the regrowth to create this bushy density from the base up. The other hedge here is established in what I think is our most common way of raising hedges. Planted, let to grow to the desired height, then trimmed repeatedly at that same height. One is providing for climate, biodiversity and farming, the other clearly is not. Now, hedge management isn't always intuitive. Alongside greater ambition for planting, we need greater education on how these incredible assets are best managed. So hedgerows have the capacity to provide rapid and meaningful progress against two of the biggest issues of our time, biodiversity decline and climate change. As a happy byproduct, they may also help future-proof our farming against some of the threats climate change will bring. To my mind, this already warrants the attention and funding needed to zoom them to the top of our collective priority lists. So can hedgerows help save the world? Well, time will tell, but they certainly do have incredible potential.